Welcome to the Unconsumed podcast. I'm here with Dr. Anthony Hylick. How you doing, Anthony?
Doing great, man. Thank you, Lee. It's good to be here.
Hey, great to have you on. So I was just, before the camera turned on here, I was just kind of iterating to you that you are very different than most of the guests that come on this show because you are one of those guys that has gone the traditional route in so many ways of getting the education. You have and I'll let you describe it. So tell us a little bit about your education and where you're going and what you're doing, or where you've been. And then I'd love to hear about what you're doing because I understand there's some news there.
So from Warner Robins, Georgia, I did undergrad at Georgia Tech, majored in computer engineering.
Okay.
And I won a Gates Cambridge scholarship my senior year. So I was one of about 30 students in the U.S. chosen to pursue graduate education at the University of Cambridge over in England. So I did that for about four and a half years, got my PhD in computer science, and then started industry research with IBM Research.
Right, and you were there for how long?
I was there 7.5 years.
Okay, so I met you at IBM. We were actually in the same training course. Do you remember this?
Absolutely. Orientation, I remember.
And yeah, we went out to New York. I'd never been to New York at the time. And we were just going out there to check things out. That was so
I think I still got that picture from Wall Street that we took.
Yeah.
I got to find it.
Yeah, well, it was taken on a 2000.
Like a flip phone, right?
Yeah, it's exactly. It was super blurry. It's funny to think of how far tech has come, like consumer tech, especially in that time.
Right.
But, so, one of the things I hear about Georgia Tech quite often isn't that one of the premier engineering schools in the United States, at least?
Absolutely. And I would even broaden that to the world. So you've got students from all over the globe that descend upon Georgia Tech for undergrad, master's, and PhD level education.
Right. So
and I would put my money on Georgia Tech graduates just the same as some people would put their money on Stanford, MIT, Berkeley, Caltech. You name the top institutions, Georgia Tech is right there with them.
Awesome. So is that really difficult to get in there?
Yeah, it is. It's a very competitive school. The professors, the education, the experience is amazing, and it ranks up there with any experience that you could have at the post-secondary level. Right,
okay. So in order to get into that type of institution out of high school, do you have to have like 4.0? Or I was growing up in the time where they started putting into those classes where they're like the college credit courses, and you could
the AP classes.
Yeah, and you could end up with like a 4.9 or something like that.
Yeah, so I think college admissions has changed a lot since both you and I were applying, and I've been a bit far removed from the undergraduate requirements, and I do know those have changed. Yes, I know there's a lot of competition around the AP courses. You've got students that have had several years worth of programming before college, and just a lot of advancement at the high school level. So and also the way they changed the SAT. So I think they added an essay portion, but then they backed out of the essay portion of the SAT. So lots of change that I'm not familiar with. So I don't know about the requirements from an undergraduate perspective per se, but obviously at the graduate level, both master's and PhD, it's about being able to distinguish yourself, to have a clear vision of what you like to research, being able to show that level of curiosity, that level of persistence that is going to be indicative of somebody that's not only going to complete the program, but somebody that's going to look to really push the boundaries of a research topic or research area. Right.
Okay. So just real quick, what are your thoughts on the whole college admission process right now? There's like some controversy in the news or in the statistics that you read, and there's a report on everything right now, or a study on absolutely everything that says it's unfair to this kid because he doesn't learn that way, or it's unfair to so-and-so because of this or that. Do you have any general thoughts on that high school to college transition?
I think the biggest thing now is everything has become so competitive. And there's a balance that needs to be maintained, that you maintain a sense of groundedness and humbleness or humility in the midst of trying to be competitive and trying to be the best. Because I think what I see, you get so wrapped up trying to be the best and going to all these extracurricular activities, you forget to be a kid.
Right.
And you see a lot of parents that really go overboard, whether it's sports or music or dance, whatever the outlet is. It's at the same time, you've got to remember these are kids, and you've got to have some type of childhood experience. And I'm not saying I know what that balance is, but it would be something that I'd be mindful of, because there's a lot more than just trying to get these scores or get these marks in order to get into a particular school. And I think the schools are starting to really reassess what their rubric is, because they understand some of the negative behaviors that have been reinforced with the current way of admitting students. So hopefully they're on top of things. Hopefully parents can really step back and see the big picture and understand that just because you don't get into school A doesn't mean your life is over. There are a lot of good schools.
Right.
And there are a lot of places where you can get a top-notch education. And nobody wants anybody committing suicide or being depressed because they didn't get into a school. And because they didn't get into a school in that particular emotional state, they've what's the word? They have potentially put themselves on a trajectory that's sublinear, sub-exponential, because they're sad or they're down because they didn't get into that school, and that shouldn't be the case.
No, that's a really, interesting thing to hit on before we even get into the meat of the story, is that, that time in your life when you're getting admitted into college and you're kind of being set on a, it can feel like this, set down a track where it's like, this is your aptitude in so many ways. This is the level that you can compete at, kind of thing, especially at the highest levels, at the levels that you attended. If it hadn't been for basketball, I don't think I would have gotten into my top 5 schools I wanted to get into, just because, I don't know why, but I wasn't going to, kill the tests or anything like that. Yeah. So, I look at your cases like you, where you were able to ace that track, and I think it's a really interesting thing for people to hear, your thoughts on it after the fact. So you mentioned you also were an athlete in high school, correct?
Yeah. Baseball and football.
Baseball and football. What positions, by the way?
Quarterback in football, shortstop in baseball.
Would that have anything to do with why Bo Jackson's on the wall?
Absolutely.
So I have an office full of posters, and some people would call them childish, but I had, you remember Bo Jackson in the Tecmo Super Bowl game?
Absolutely.
He was rated in some editorial somewhere as the greatest video game athlete of all time. And so it's 36 by 24, 8-bit Bo Jackson. It's like the whole poster is probably 100 pixels.
I would love it. Oh, I need to go Google that. I need that.
Yeah, find that. I'll tell you what, I'll send you one as a gift for coming on the podcast. And the other thing is, thanks for coming on. And I know we tried to do this in the office here, but Anthony Hylick's a busy man, and I gotta bide my time and get him when I can get him, right? Well, great. So you moved from Georgia Tech. It's the top of the heap as far as the undergraduate goes, and then you get this scholarship to go to Cambridge, and that's where it goes from like, so top of the heap to transcendent in a lot of ways, right? So you go, it's one of the best credentials you can have as someone going into the tech world. Am I incorrect?
It's one of them, yeah, absolutely.
And so tell me how you got that, and what was the process? What happened there?
So Cambridge was interesting because I initially was only wanting to do a 1 year at Cambridge, a 1 year master's, and then I was probably going to go to Berkeley or somewhere else, because I had a full President's Scholarship to attend Berkeley for graduate school as well. Okay. And my advisor at the time, I can remember getting on the phone, one of the, what was her title? Amanda Gable is her name, but she was one of the coordinators of the prestigious fellowships program at Georgia Tech. So she had arranged for me to get on the phone with my would-be advisor. Okay. And I mentioned that I wanted to do a 1 year, and he cut me off full stop. Hey, I only accept PhD students, and that was it. So that's how I wound up doing my PhD.
Okay.
Because I didn't want to go to any other group. I didn't want to have any other advisors but this guy, Andy Hopper.
Okay.
And so it turns out that was a tremendous experience, with Cambridge being a premier destination from people all over the world. You're talking about kings and princes, aristocracy. This is where they're sending their kids, right?
Right.
And so you're rubbing shoulders with the best violin players in the world and all kind of craziness. And they're just regular people. They just want to hang out, have a good time, laugh, joke, just like the next person, have a good meal. And with that, you just get so many different people that have so many different backgrounds, and you can imagine just the stories and the conversations that you can have.
I bet.
And what was also, so being from Georgia, never having been out of the country before, going to Cambridge, it was a great opportunity for me to see different culture, a different experience, a different way of seeing life. So America is very American dream, house, white picket fence, 2.5 kids. And it's very easy to think that everybody thinks like that, to think that everybody's ideal is what we call the American dream, and it's not. And to see that people value so much more in life than just the house and the 2.5 kids, that really helped me to recalibrate my view of life, my view of what it meant to be happy, my view of goals and the life that I wanted.
Do you think you had to go to Cambridge to come to that, or do you think that's something that could have happened at what's a community college in Georgia? You know.
I don't believe so. I think I needed to get out of the U.S. to see that. Whether I could have gone to Canada or Mexico or South America, I don't know. But it definitely, I think it required me to leave America and to see a different view of the world, of life, of family and relationships that way.
Okay, interesting. So you're out there and you're studying to be a PhD in computer science, and like I know for me, if I could cheat my way into Cambridge, it wouldn't go well because I wouldn't pass, right? So tell me about like how difficult are the actual classes there? Is it a catastrophe, or are people just like, and you mentioned like depression of kids based on the challenges that they're coming to? Is it that heavy?
It's different. I think the level of competition is the same because the stakes are high there as well, and you do feel that sense of pressure, that sense of expectation. What's slightly different in the UK, at least what I saw. So I think in America we've got this notion that everybody's going to college, whereas 30, 40, 50 years ago that wasn't the case. But it seems more now that everybody's landing place after high school is college. And part of that is because we've got so many different scholarships that help finance going to university, so many different programs to help you get to college after high school. In the UK, there wasn't this abundance of scholarships. So you weren't really going to school unless your parents could afford it or you could afford to pay. So there was still very much this sense of we're going to send our best and brightest, and if you didn't make the cut, well, figure it out. And that's very reminiscent of, I think, a time 30, 40, 50 years ago where you had these larger families, 6, 7, 8 siblings. Not all of them went to college.
Right.
And sometimes you had to make family sacrifices to send those children that were going to go to college. And I can imagine what that decision is like as a parent, to look at your children and say, well, who's going to go to college? That's got to be a tough decision.
Right.
And that's not to say all families that had large families like that, because I know some families that sent all their kids to college, and it's amazing how they did that in the 40s and 50s, but that wasn't everybody's experience. And as a result, in Cambridge, you really saw people that wanted to be in college, and you saw them that really accepted the responsibility and understood what it meant for them to be in college. So there was there was a level of professionalism. There was a level of I've got a job to do that was slightly different than what I can remember seeing in the U.S.
That's really interesting because I always tell this story about a guy I knew in college who worked at the Toyota dealership to pay for college. And he brought this whole new perspective to the table of, yeah, I'm not going to screw around in class, and I have obligation to myself and to my family. And oh, by the way, if I mess this up, I'm going to have to work another 80 hours at the dealership and get lucky enough to sell, 3 Hondas, they're Toyotas actually, to redo it, right? And so I just think there is when the onus is on the individual and there's some sort of, I don't know, you're responsible for something, whether it's to yourself or to family. I think that goes a long way in defining like what your purpose is in that frame of life. Yeah. And then one other thing I wanted to mention is that when you're going from high school to college, and even from college to post-grad or your first roles in the professional world, your brain isn't even fully developed yet. So it's like these times, I'm thinking like 17, 18, when you're making that jump from high school to college, it's like a lot of people can't really deal with failure or perceived failure at that point. Even though it may or may not be, it's just like, I don't have any mechanisms to handle this yet. And I've been protected from failing, or I just don't know how to do it. And then that happens again right after college for a lot of people when they're trying to get a job, their first job, and they interviewed at Enterprise Rent-A-Car and it didn't go well. And so they're trying to find something else. And it's like there's these two major points right on the bookends of when people are at the end of educational processes where you're just thrown to the wolves in terms of like, hey, go see what the market has for you. Yeah. And I think there are people that thrive in that, and there are people that just die in that. And I don't know if there's any solution for that. I think that might just be part of the shtick that we're performing here. Do you have any ideas on that, or like is that out of left field?
No, it's not out of left field, and I think one of the ways that I feel like I was prepared to handle this is playing sports. Mm-hmm. And I know sports may not be everybody's thing, but some activity where there's a sense of competition, whether it's violin, whether it's dance, and something where there's a winner and a loser.
Who's the loser at violin? Second chair?
Yeah, these violin competitions. Who is second in the world in violin and not number one? So if you're not first, you're last. Ricky Bobby.
I love it. Hey, speaking of which, before you end that off, can you rattle me off like a quick funny list of who was at Cambridge that would be funny to hear? Like you mentioned princes and things.
I don't remember names. Lee.
Or you don't need to remember names. It's like, I think it's funny, like an oil sheik or like the prince of some random country or something like that.
Yeah, you see. So there were some Middle Eastern folks that I remember. I think there was this one guy who was like the third best violin player in the world. He had played for the Queen, and he was just talking about some of they were Russian. The top players were Russian, and he was describing their practice regimen and how much they practiced, and it was just insane. Who else do I remember?
Well, you saw Icarus, right?
Yeah.
they're doping, obviously.
The rowers, the rugby players, you would see them around campus, and these guys were just huge. So it was interesting, and again, they're just regular people, right? So you see them around town having a drink, having a meal.
I was hoping you'd say like Kim Jong-un's brother or something was there. And
if he was, I don't know.
Okay, so sorry to cut you off on the point. Yeah.
Yeah, with sports, that's one way I think that helps to give you that practice and that experience, feeling what it's like to get punched in the mouth, right? Mm-hmm. And really understand how you're going to respond when life kind of catches you with one. And I think so. I've been a huge fan of Dr. Carol Dweck's work at Stanford. She is the author of Mindset, and it's a book that talks about growth mindset versus fixed mindset, where somebody with a growth mindset understands that your intellectual capability is not something that's static, but something that's dynamic, that grows, that changes, that can be improved upon. And anytime you come up short, that's just an opportunity to figure out what you did wrong and fix it and to get better at it. Whereas somebody with a fixed mindset, they come at it from a standpoint of, I've got this finite level of intellectual capacity, and if I fail, then that means I'm a failure and I'm not good, and it starts this negative reinforcement cycle. So to somebody that comes out of high school and doesn't get into that top choice, are they going to look at that and say, you know what, well, maybe that school wasn't for me, or their loss, and move on to the next school? Or are they going to say, oh, I didn't get in, something's wrong with me, right, let me go crawl in a ball in a corner and be sad?
Yeah, so I heard something really interesting this week, and it's around IQ. And so are you familiar with any of the studies in IQ over the past, I guess it would be 60, 70 years?
Yeah, I read something, I want to say about a year, 18 months ago, where, and it's funny you mentioned this, so with fixed and growth mindset, they say your IQ is static after 16, 17 or some age, and it doesn't change. But I think the research shows that you can gain a few points. So your IQ is relatively set, but there is a way to increase your cognitive capacity, your intellectual capacity past the simple measure that is IQ. That's what I remember.
Yeah, so I was reading about this, and it's that the United States military will not accept anyone with sub 83 IQ, because anything that they would get into in a military capacity would potentially be counterproductive. And it's not one of those things people like to talk about, because it's 1 in 10 people have that 83. And the military is ultimately incentivized to get as many people as they can into the military. So I'm like, well, shoot, that doesn't make a lot of sense. And those are the people that have been studying those longest. And it's juxtaposed to the growth mindset play, right? So it's like you're given this certain quality. So if I'm right at 83 and I bust my tail to get to 84, then, does that put me over some kind of line where I can be productive? I don't know. And I think one thing that is really interesting that we do need to take into account is that people are pretty magnificent creatures, and they can surprise you all the time, right?
Absolutely.
So, if a guy's got an 82 IQ, and that gentleman's probably not taking a lot of IQ tests by virtue of the fact that he doesn't want to. I wouldn't want to. Watch out. People can surprise you. So I think that's that balance that I think exists there. But I think if I'm putting a stake in the ground, I'm going to lean towards the growth mindset, because I don't want to have that negative opinion of the world. Right. But then at the same time, I don't want to ignore all these facts, right?
Sure.
Or history, or the statistics. I don't know. What do you want to call it?
Right. And I think we also have to make a distinction between IQ and value. Just because your IQ isn't a certain number doesn't mean you can't add value. And so how do we define value? How do we define productivity? So those are the bigger questions we have to ask, because there's too much assumption in just saying, oh, your IQ isn't high enough. Well, what does that really mean? What's the objective here?
Right. Well, in the Army, it's war fighting and war winning, as they say. But it's that's one of those questions that I love to bounce off guys like you, because I get myself thinking about it at my desk late at night. I'm like spinning around, and I don't know. I got to call somebody. So cool. So you go through Cambridge, and it'll bring us to the time where I meet you at IBM. And what year would this have been? 07, 08, something like that?
No, it was 2010.
2010. Okay.
Yeah.
And so you were out there, and I was taking a sales gig, as people that watch this podcast know. I'm one of those sales guys. But you were there for the IBM Research division, and that is an entirely different part of the world than I was in. And these are, essentially the smartest people that IBM can find, and they get to go after the pool of the entire Earth's inhabitants, and then they select you for a specific project. So can you tell me about the projects you've worked on as far as you can without breaching any issues with the old Big Blue or IBM Watson, who's probably listening right now.
So I did my PhD in disk drive energy consumption. So being able to look at detailed power profiles and detailed characterizations of disk drive energy consumption. And I was able to write a model that, given a series of block requests that you're going to send to this hard disk drive, how much energy is that going to consume? And from energy, you could back into how much money is that going to cost. And once you know how much energy it's going to consume, you can do different things in terms of scheduling those block requests to make the disk drive more efficient in serving those blocks and reducing how much they're going to cost.
Gotcha.
At the time, data centers were just really blowing up. So this is 2007, 2008. So if you can think of saving 20 cents on one disk drive, but a place like Google, for example, that has unlimited storage for Google Photos now, you can imagine how many disk drives they have. And 20 cents multiplied by 10 million, that's some serious cash. And so it really adds up. So
yeah, that's one really interesting thing that I think is lost on humans now, especially the consumers, is that when you go on your phone and you upload that photo, it's not just disappearing or it's not going on your phone. It's just going on someone else's essentially gigantic phone that they put out in a desert somewhere. Or as Microsoft is doing last week, they're dropping data centers and storage centers into the ocean. Yeah. Well, that's a great way to reduce heating and cooling costs, at least for your model, right?
Right. So that exploration led me into a passion for power management.
Right.
At the server level, at the data center level, and continued interest at the storage level. And the Austin Research Lab, where I joined IBM, they had a very prominent power management group. And so I was able to come in and to add an area of expertise around storage that they didn't have. And so some of the early projects that I was working on were focused on how do you augment solid state storage, which was just becoming popular at the time. This is 2010, 2011, with traditional mechanical disks, so spinning disks, in order to spin the mechanical disk down into low power states while being able to sustain the workload requests with the SSDs. Gotcha. So you can imagine how little SSD capacity do you need in front of this mechanical storage in order to save 80-90% of your energy consumption while still being able to serve the requests coming in. Essentially, what why we were able to do that is we profiled workloads to see that only 10% of the data was being accessed. So if that 10% of the data is on the solid state drive, the 90% of the data that's only going to be accessed once a week, once a month, whatever, can be spun down into lower power states.
Right. So is this the advent of archiving your mail and all that stuff, or does that come before? Similar
concept. Archiving email came before that, but it's a similar concept in terms of the long tail of data access. So there's a small number of files that you access all the time, and then you've got photos or emails that you never ever look at. Right.
So are you familiar with Amazon Glacier?
Yeah. Mm-hmm.
So it's the S3 Glacier comparison?
Correct.
Okay. So it's, for those of you that don't know or don't care, we'll make this real simple. One is for quick moving access, things that you need all the time, and then they're going to take a lot of power. And then there's Glacier, which is essentially things you're going to use once a year, but you can't get rid of because you might need them. Right. Essentially, it's like your desk drawer versus the top of your desk, right?
And that was exactly the analogy I was going to use is your CD case. So you can, if you remember when we actually carried around CDs in our car, we had like the large 500 CD binder that we may have kept in the trunk or the house. And then we, in the visor on our car, we had that 12 CD sleeve, right? So that's for the quick CDs that you want to listen to. But if you want something from the archives, you got to stop the car, get out the trunk, and get the CD out.
Yeah, and it's funny that you mentioned the CD thing, because even if you are using all the modern services, for instance, Spotify is the one I prefer. And so if I go on Spotify, it's a great service. If I go on Spotify and I don't know what I want to listen to, I'm just going to go back to the same old things. And so if I want to reach into the archive, essentially, I've got to go digging around, and it's time consuming. It's like stopping the car, going in the trunk, and finding a new playlist. Or I'll play something from long ago that I haven't listened to in a while, and it's that same, quick touch, low touch, or high touch, low touch feel for that applies to cloud and disk storage. So what else did you work on at IBM? So that's two really cool things.
Right. So from that project, I expanded my expertise to include big data file systems. So Hadoop, if you're familiar with big data analytics.
That lovely elephant.
Yes, the lovely elephant. And specifically what I was interested in is, so Hadoop is great at processing a large corpus of data for a given query. So how many words are how many instances of each word are in this major corpus that I have?
Corpus. And what do you mean by corpus?
A big pile of data. Is that
a data term, or is that just I'm a doctor term?
It's a pretty popular term in the industry.
I have not heard corpus. I've heard data set. I've heard cluster. I've heard hive and all these types of things. Corpus.
Yes. And if so, one thing I realized is if you ask a question and you've got to look through all of this data to answer it, number one, you may want a response before you can spend the time to look through all the data. So that's the first thing. The response time for looking through everything may be too slow. The second thing is, just because you look through all of the data doesn't mean you're going to get closer to the answer. So some of the data may be getting you closer to the real answer, and some of the data may be pushing you away from the real answer. So how do you know what's the good data versus what's the nefarious data in terms of getting you to that end goal of answering this question that you've asked?
Right.
So what I was thinking of is there a way to kind of tag or know what each data item that you've ingested into that corpus, if you could kind of tag it to say this is about sports, or this is about music, or this is about technology. That way, when you had a question come in, you could kind of match the question to, is this question about sports or education or exercise or food?
Right.
And then when you look at, okay, well, what data in my corpus do I need to answer this question? You could say, well, it's not about music, so I can exclude all my music. Right. So not only do you reduce the amount of data that you have to process to answer the question, which speeds up your response time, but also you don't run into the situation where you're looking at data that's pushing you away from the true answer that you want. And this was the next project that I worked on, and this led me to the last project before I transitioned to the research headquarters in Yorktown Heights, and that project was graph databases.
So before you go off on graph databases, so I lived in Chicago, Illinois, and then you were in Austin, Texas.
Yeah.
And then I moved to Austin, Texas, and then you immediately moved to New York. What gives, man?
One of us had to be in a cold climate location. We couldn't both be in the heat, right?
Well, I hope you don't move back here, because that would send me back north.
No shovel and stove for me. I'm done.
Fair enough.
So graph databases, just being able to have a much more flexible representation of your data. So essentially what I realized is that I wanted to be able to look at my data differently based upon what I was going to ask of my data. So I wanted to be able to put a different lens based upon the question in order to see my data in the most optimal way for that particular
question, query.
Yeah, question, yeah. Or what's the word that I'm looking for? That that particular
hypotheses, theory.
So the view, so that particular view that the question is causing me to see, that's the view that I want to view my data. Yes.
Yeah, interesting. So I come from I spent 3 years at Tableau, so I've looked at data sets upon data sets about things that are awesome and things that I couldn't care less about. And everyone is asking these questions because it's not when people outside of the industry hear the term big data, they're thinking, okay, so it's like a really big spreadsheet. It's like one that your computer might struggle with. But no, this is data, like a data ocean almost, right? Mm-hmm. It's looking at, okay, so let's use the example of like Walmart, right? So every time you swipe your credit card at Walmart, it's taking down your name, it's taking down your address, it's taking down your phone number, it's taking down the SKU of what you bought, what time of day it was, and think about how many times that credit card is swiped at your local Walmart. Mm-hmm. And then extrapolate that across all the Walmarts in the United States, mm-hmm. and then all the ones worldwide, and they're going 24 hours a day. Mm-hmm. Think of how much data that creates, and some poor soul in an office somewhere, probably in a cold climate, is having to parse through all of this and make sense of it. And so I think for the first time in modern history, people are actually making significant strides towards being able to make sense of all this stuff. And that's what will inform, essentially machine learning. And we say the word AI every day on this podcast, but it's the precursor of what informs all of these different systems that would come into place. So if Walmart ever wants to play AI, and they definitely will, mm-hmm. That's the data they're going to use. And AI can be a lot of things. I think people think of it as robots. I like to think of it most as robots. But it's advertisements for you. It's if you walk in the store and a camera recognizes you, they'll hand you a coupon for the 10 things you like to buy the most. And this is the type of big data analysis that goes on in the background of that.
Correct.
And so I guess there's a funny anecdote here, is that this is right around the time that you and I were working on a project, and we called it Flyby Inc. Do you remember that?
Yes, I remember that.
Okay.
So we had a great logo.
We did have a great logo. I think my sister made it. Can you, and so I'll put you on the spot here, because I was thinking about this while we were setting up for tonight. Can you describe what Flyby was supposed to do? And this would be 8 years after the fact, 7 years after the fact.
Yeah, absolutely. So unbeknownst to us at the time, and maybe in our inexperience at reading market trends, we
were children.
we failed to see the proliferation of phones, tablets, and everybody having their laptop.
It was right on the edge of that. Yep.
If you can imagine 2005, 2006, on a college campus where computer labs are a thing. Now, mm-hmm. You might say computer lab, and people look at you like, what in the heck is that? So a computer lab was a place on campus where you could go use a computer if you weren't in your dorm room where your desktop computer was.
Right.
Or if you had a laptop and you didn't carry it around everywhere. It was in your dorm room and you needed to print something out, you needed to check email, you needed to do something online. And these computer labs were public computers. They were public access computers, and you had to put in your password to log into the campus network, and then you had to put in your Gmail password, and if you were going to do banking, you had to put in your banking password. If you were still on Yahoo or Hotmail, whatever.
I'm still on Yahoo, bro. I got a Gmail too, don't judge me.
And so all these passwords, so not only was this insecure because these were public machines, putting in your password was very time consuming, mm-hmm. and it was repetitive. And what we were thinking of, if there was a way to have a small USB token, a USB key that you could carry around with you, you put it into the computer, you unlock the security key, the USB key, and for the rest of the time you were using that computer, you didn't have to type any passwords.
Yes, and it was beautiful.
That's the notion of flyby. So you're flying by at the computer very quickly. It's quick.
Yes.
It was secure, it sped things up, and it was really darn cool. Again, at the time, this was 2009, 2010.
This was between the XP and Vista release. You remember this?
Yes.
Yes.
And so I think where we really missed the market turn was I didn't see smartphones, tablets, laptops proliferating like they did in terms of everybody's got a laptop, everybody's got a tablet, everybody's got a phone all the time. Mm-hmm. I think also with mobile apps, I didn't see that coming. And essentially what happened is the idea was out of date. So had we come out with this idea probably 2000, it's money. Lee and I are having a way different conversation. It's probably on a boat somewhere. We got cigars. We got some bourbon. It's a way different conversation.
We do that anyways.
Yes, we do.
So it's funny you mentioned that because this is it was a great idea executed by a couple guys that weren't quite ready to maybe execute on these ideas. Poor market fit, and these are all things that you kind of pick up as you're, learning about all these things. But then the current day version of this is LastPass.
Right.
And that's a huge app. I mean, I don't know too terribly many people that don't subscribe to that. Right. And it's the same thing. And then Apple has their keychain, and that came out a little bit after the fact too. So I thought the idea was great. And I bring up this story just to prove that you can have absolutely great ideas that are poorly executed or they don't fit the market at the right time in the right place, and that is a major, that'll make them stop. Right. So I love that story because it's one of those times when there was a lot of failure, but there was a ton of learning to be able to be done, and it informed how I should look at the rest of my entrepreneurial career and even some of the things I do in the corporate world. Yeah.
I think you're absolutely right with LastPass. The idea is solid. Maybe the value prop is more so you don't want to remember all of these different passwords on all of these different sites, and it's more of a security play so people don't use passwords over. But the fundamental idea is exactly the same. Obviously, it's based on your mobile phone or some cloud-based service, as opposed to having to carry around a physical USB key.
Right.
But the idea is solid, and we weren't necessarily wrong. The timing was off. Maybe the market fit was off, and maybe we led with a value proposition that wasn't as valuable as we thought.
Yeah, it was an interesting thing. I thought it was worth doing, and I had just been on a patent committee at IBM, so I was around a lot of people thinking a lot about things that were a little off the wall. And IBM is known to be, the number one
patent
corporation. Mm-hmm. Yeah, patent generator. I was going to say patent troll. That's not nice.
No, IBM doesn't do too much trolling.
Well, I've seen some patents go through that were a little bit off the wall, but that's
trolling in the sense where you just go after people and you make the case that they're infringing on your patents.
Yeah, well, they're not the top. They're definitely not the top troll in that category, but they definitely are trying to get as many patents as they can because they want someone else to try to take claim or technology to hit there. So that's one of those things. So this leads to the question of how many patents do you have now?
7 or 8, I believe.
Don't you have a quota at IBM as a researcher to create quotas or patents?
There wasn't quota. We definitely were incentivized, and patent generation was something that was looked on very positively.
Gotcha.
But there wasn't ever somebody saying, "Oh, you got to get X many patents now."
Okay. So at this point,
I think that would have incentivized the wrong behavior if you start doing things like that.
I completely agree. So I had run across a guy at IBM who had 47 patents, and that was. As I'm assuming not super rare either.
Oh, no. 47 isn't a lot.
Okay, throw me a number that's a lot. What would someone say to you that would be impressive to you? Is this is how many patents I have?
I think having been at IBM, over 200 is where I really say, wow, that's impressive.
Wow, 200 patents. That's 200 new, different, and non-obvious ideas coming out of one brain. That's pretty cool.
Yeah.
Is that does every tech company have? Obviously, everyone's got an R&D team. Is this something that would be common around the industry?
200 for an individual.
For an individual, or like maybe 3 or 4 of those guys walking around.
No, that's not common. Yeah, having 200 or more patents is not common.
But is it common, like, is there one of those at an Apple, one of those at a Google, one of those at a Samsung?
I honestly don't know. I would imagine you've got one, especially now that we're moving into an area of machine learning and the pace of the industry is just moving so rapidly. There's probably a lot of intellectual property that you could write up that would be patentable, but I just don't know for sure. I don't have visibility there to really say, yeah, I think there's somebody at Apple or somebody at Google there.
Gotcha. Okay, so this puts us at the time in your career where you're in New York, doing this big data stuff, big query stuff, and then where does that take you from there?
I think from seeing where the industry was going, understanding the importance of data, I wanted to learn and experience what this machine learning stuff was all about. So I spent about 18 months learning, educating myself about machine learning such that I could contribute there in the field. Okay.
So what were your takeaways? Can you break it down in kind of like what I learned about machine learning in 18 months to the person that doesn't know very much about machine learning? Like how could you convey what that is and what it looks like? What's your takeaway?
So machine learning is simply pattern recognition. And if we talk about machine learning, artificial intelligence as being a field that's trying to mimic human intelligence with computing, and even artificial neural networks were initially designed to mimic the neural networks in our brain, the synapses in our brain. So there's a parallel there. And the fact that we're using words now, so we're essentially making sounds with our mouths, and the patterns we recognize are words, and then we can synthesize and understand what's going on in my brain. Right. So whether it be I can see Lee's face, and I know that's Lee because that's the pattern that I recognize. Our brains do this so naturally, we don't really understand these are patterns that we're recognizing, but that's essentially what's happening. And that was one of the really interesting things to understand, that the math and the implementation of a lot of these machine learning and neural networks is being able to learn the pattern in order to make the right prediction.
Okay, interesting. So can you give me an application for how you'd play that out, or what were you studying watching this play out?
So you mentioned Walmart, right? So yeah. So somebody in Oregon buys, what do they buy in Oregon? Some winter gloves, right? So somebody in Oregon buys some winter gloves, and it's 11 o'clock at night, and they also buy hot chocolate since they're there. So if there's some way that Walmart could capture, all right, the person that's buying winter gloves and hot chocolate at night, this person that made this purchase also likes this type of DVD, for example. So imagine they're shopping on Amazon, or excuse me, so imagine they're doing this shopping online, and Amazon can track these other purchases that you've made.
Right.
Now, if the individual in Oregon looks like the individual in, say, Chicago, then that pattern is, okay, these people probably like the same thing. So let me serve this person some ads, or some provide them some offers, or discount codes for these similar products because these people are similar.
Right.
So the patterns of behavior is essentially what we're able to uncover from a lot of this shopping and retail data, whether it be time of day, whether it be time of year, whether it be the co-occurrence of purchase items, so what things were bought together.
Right.
And over time, you generate a profile of this person and these personas that like X. And this is one way that you can do recommendations. So the way Amazon says people that bought this book also bought these things.
Right.
Or Netflix, after you finish watching a movie, Netflix says, oh, well, you may like these other movies because you fit in this cluster of humans that like Last Chance U or whatever it is you like on Netflix.
I do like Last Chance U.
Yeah, it's awesome.
So this begs the question, just because I like something that, like, for instance, there's one-off things that I like, and I think the more we talk a lot about people that are willing to try things and how that's a great attribute to have. Like, I'll sit down and I'll watch a documentary about something that I don't care about because I want to learn about it. Mm-hmm. But now Netflix is saying, oh, you watched this documentary about, let's use that fast food one, Supersize Me, because that's the one everyone talks about. And now it's sending me all these documentaries and films about why eating meat is bad and why fast food and big corporations are bad. That's not what I want to watch.
Right.
So it's like I'm getting clustered just by virtue of curiosity.
Correct.
And so I don't know, like, there's not a fix for that, obviously. Or does the pattern recognition say this guy's all over the place? Like, here's the core few things he likes, or how do you take all those exceptions in?
Well, so let me start by saying this is why the robots aren't going to take over anytime soon, because the algorithms aren't where they need to be. So if you take movie recommendations, for example, a lot of times, a lot of what they recommend, you're not interested in at all. The recommendations are actually quite bad.
Well, yeah. So you're going to say the robots aren't going to take over. The robots. So I like to hypothesize here. let's say what someone said on this podcast, like, what if AI ran the military?
Oh, gosh.
Okay, so that's a pretty wild thing to think. Or, like, I brought up the idea of what if we elected an AI president and some AI members of Congress and Senate, and they would all they would do is execute whatever agenda the electorate put forth. And then the algorithms aren't where they need to be. So these robots start executing things that are completely not what you want. Or if you're being selected based on some pattern for things that the government does, and then they're all wrong. So it's like I think the brains behind all these things have to come a long way before, like, they can start being empowered in any way. And I just think that there's such a hustle to bring these technologies forward. Like blockchain is one that everyone has been talking about for the past, I don't know, what do you say, year? It's fallen off a little bit in the past 4 months.
About 2.5, 3 years.
Well, so it's really, like, in your circles, it's been on for 2 years. So I started doing the Bitcoin thing in 13, but it became something that you could turn on CNBC and hear about. There we go. And it became like they have a Bitcoin ticker on.
Exactly.
And so I just think, like, there's such an appetite to bring these technologies to the forefront, and they're not ready.
Correct.
And so, I look at Bitcoin and I think, yeah, Bitcoin's not ready. You know why I know that? Because Ethereum came right behind it, and it's way better. So I don't know. I'm going on a riff here because I look at the tech, and I live in tech, and I sell tech, and I look at a lot of the technologies that exist that are cutting edge, and they're not ready to be what people want them to be. And technology takes a long time, and I guess you're the right guy to have this conversation with, because you're the guy building it. You're the guy creating the models. You're the guy writing the actual algorithm. And it's funny, the word algorithm, because nothing backs someone off like the word algorithm. Oh, this guy knows what he's talking about because he said algorithm. You find that?
I think I asked a gate agent at an airport. She was making some decisions about who could get on the plane and how people. I was like, "What algorithm are you using?" And she just looked at me like I had three heads because it was totally random. Mm-hmm. And I think she wanted to make it seem like there was some process, but it was I couldn't detect the pattern. So I asked her, "What's your algorithm here?" Mm-hmm. I didn't make a friend there, I don't think.
Yeah, so, model is the other one. That's
the tech isn't there. Machine learning has a ways to go, and I was trying to think. I was reading a book, and it talked about the difference between competence and capability.
Oh, that's a great subject.
And I'm not sure if capability was the other side of the coin, but competence was definitely one. And the argument was this: because we give too much, we apply too much of human characteristic to the AI. And this is what I mean by that. So because you can count to 10, Lee, and you can recognize hot, cold faces, you can do other things. You probably can run, you probably can jump, you probably can do these other things. However, just because a machine learning model is very good at detecting cats, that machine learning model can't tell you if you've got the right ingredients to make cookies or not.
Right.
So the machine learning is very good in its very narrow domain that it's been trained in, and it can't get outside of that box. You can't move it into any other lane. So with humans, if somebody is really, really good at something, you can probably pivot them to the side, and they're still going to be pretty good at whatever that side pivot is.
Okay.
And that's what I mean when I say we apply human characteristics to the ML.
Yeah, there's this old Seinfeld bit where he says, you ever heard what I'm talking about?
No.
He's like, everything that we've made the machine world do is just mimicking like what we would have done with our hands. Like when the guys are driving in the car and the windshield wipers are going like this. It's just like when the guy would get outside the car and go like this, and then we make a machine that does exactly that, right? And I think that's so funny because it really hits the machine learning world in so many ways. We're trying to make machines be like humans, and I don't necessarily know that that's exactly what we want, is it?
Oh, that's a big question for a whole new podcast. Let me put a pin in that and come back to that in like 30 seconds. So the fundamental challenge in the field about ML not being able to pivot is we use a term called generalizing. But machine learning doesn't generalize. Just because you do this doesn't mean you can generalize about your competence or capability that you can do these other things.
Gotcha.
And until we can get generalizable AI, so a bot that can vacuum my floor and clean my toilets, those type. Once you can start to do, it can do this and this. That's when we really will start to get some really potential 0 to 1 type of machine learning and AI.
Okay, so give me a really conservative and a really aggressive thumb in the air around how long you think it will take for Roomba to be able to go up and clean the rest of the bathroom, or for let's think. What's another piece of AI that's out there? So, like, how long until Netflix can actually recommend me a show that I want?
The Roomba, because you've got mechanical challenges there, and those mechanical challenges are expensive. So, if it's going to be a reasonably priced thing, I would say.
Well,
aside from cost and the mechanical challenges, how
think
long
about that college kid, that guy you met at Cambridge, money is no object.
How long would it take? I imagine within. It's. I'll give two answers. It's either within 2 to 3 years, or it's going to be 5 to 10 years.
Okay.
And the 5 to 10 years is on the back end of another AI winter. I think we may be on the cusp of, we're at the ceiling of the advancement of AI right now with our current computing capability, our current knowledge, our current approach with neural networks. We may be at the ceiling, and we may need another breakthrough in the industry to get to that next plateau that allows for this type of generalizing AI.
So are you familiar, I'm sure you are, with like quantum computing and all that stuff? That isn't enough horsepower to get this done? Because it sounded like just obscene to me.
With quantum, we've got to figure out how to map these problems into quantum computing terms. So we've got to figure out how do we map these into quantum computing terms. And quantum computing is just that, it's computing. It's not learning. So there's still the need to learn something, because we can't program all of these if-else statements. We can't put a set of rules together. It's just too many rules. There's just infinite amount of possibility.
Yeah.
Tesla's doesn't have autopilot because they have the best rule book for how to drive. No, they've got miles and miles and hours of driving and video that they create a model on, right?
Yeah.
As for what was the other thing? AI to replace humans or to do what humans do. What was your question?
So I was asking for the conservative answer, and that is, your conservative answer of 5 to 10 years is we've hit a ceiling, and then there's an aggressive track, which is 2 to 3 years. And what do you think would have to happen for that to occur?
I think we just need to make some more advancements into learning algorithms. So as opposed to just learning tasks, this is how you vacuum a floor, but an algorithm for cleaning in general. This is how you clean. And that's a field where you broaden the learning capability into a set of tasks that you're learning, as opposed to just a single task.
Yeah, it's a wild thing to think about, and especially tech overall is just such an interesting thing, because there's no limits on what can be done, and history doesn't seem to matter very much about what's going to happen in the future, which is one of the only things I think you can say that about, right?
History doesn't care about what's going to happen in the future.
But the future cares about, or it's specifically in technology. Technology doesn't care what happened historically. It doesn't take any real cues from history in order to be what it is going to be in the future.
I think I would disagree. I think we're very dialed into what's happened in the past, and what's happening is people are just inventing new and better ways to do what we've done before. So a lot of the problems in computing are the same problems that people have been researching for years. And now we've got more computing power. We've got smaller form factors for computing devices. We've got improved technological processes.
Right.
We've got a lot of improvements, so we can make a lot of what happened better. And even with AI, for example, a lot of the algorithms that we're using today, they were defined back in the 60s. But in the 60s, they didn't have the data, they didn't have the compute horsepower to actually code them up and actually run them. So the fact that we can actually run experiments now is allowing us to iterate much faster to improve upon those theories and those algorithms from way back when.
Okay. I got a tangent for you. Tell me, who's your tech hero?
Ooh, tech hero.
Who's your favorite technologist over time?
I'll go with 3.
You can give me a Mount Rushmore if that's easier for you.
I think I'll go 4.
All right, let's have it.
Isaac Newton, Albert Einstein, Richard Feynman, and Booker T. Washington.
Okay, that's a good crew.
Yeah.
Who's number one and why? You're on the internet, bro. No escaping this. It's a long form interview. You're on the spot. We got time. We got nothing but time.
I think Isaac Newton has to be number one. A fellow Cambridge graduate, by the way.
Okay, so there's an alignment. Geez, that'd be so cool to say that you went to the same college.
To be able to
Newton.
To be able to understand your scientific problem so well to know that you need to invent a math to continue is mind blowing.
That's pretty pure.
And to do that in a time where you had such rudimentary tools about you, and to be able to do those thought experiments and to really logic and reason through some very complex concepts is mind blowing.
Yeah.
Just true genius at its finest.
That's very cool. Yeah, if I was going to rattle off a few of my favorites, if people are interested in it, like what's out there to review, you ever hear of a guy named Nicholas Negroponte?
That last name is familiar.
He is the guy. He's the founder of the MIT Research Lab, I think it's what it's called, or the Media Lab is what it's called. And he does all these TED Talks about the explanation of all these major tech booms over time and like what's possible and what was the origination of us even thinking about a lot of these things that you hear about a lot right now, like big data, virtual reality, all these different things. They track it over time, and it's just fascinating to me. And then I think I love Wozniak because I identify with the practitioner over the vision guy. I think the vision guy gets too much credit most times.
Yeah.
And then I'll also take. Well, I don't want to put them on the list. Forward on. So where are you right now in terms of where are things going for you? Because when we turn on the podcast, I noticed that it's still light outside, and where I am, it is almost 10 o'clock. So that puts you on the West Coast, squarely on the West Coast, or Australia maybe, I don't know.
I'm in Silicon Valley now.
Okay, what are you doing out there?
Yeah, I'm out here with Google.
Okay.
I work in their cloud division.
Okay, so I got to ask you two things. What is the interview process like with Google? Is it something, in your role, are they just like beating down your door trying to get you to come over, or do you have to go through these rigorous processes that you hear about all the time?
They do a good job of going after the people that they're interested in, and even when they do go after you, you still have to interview. It's not like they say, hey, here's an odd job offer, sign it. No, you still have to go through the rigor of the interview process.
Right. And is it one of those things where there's like 10 rounds and it's tell me how many ping pong balls fit in the Empire State Building kind of thing?
Google doesn't ask those questions anymore. Those brain teaser questions. They are very diligent in understanding your thought process and how you approach problems. Yes.
Gotcha. Interesting. Okay, so what are you doing there? What's in the next chapter for Dr. Anthony Hylick?
Just to continue to move up the business and technical leadership chain. So to move away from writing lines of code and to really start to manage and direct programs and products from a business and technical leadership perspective.
Okay.
Specifically focused in AI, the areas of AI, machine learning still.
Okay, very interesting. If you were gonna call out one piece of technology that you think is going to be the place to be and a major mover in the market in the next 5 years, what is it? I think I have, based on our conversation, I think I know. Is it AI? Is it machine learning, or is there something else?
It's indirectly connected to AI. Well, maybe it's directly connected. So one is directly connected, one is indirectly connected. So the first thing is being able to explain AI. So what's happening? So why did the car veer to the right and jump the curb? Why did it do that? So to really be able to put human language to the black box that is a machine learning model, to understand why it's doing what it's doing. So that's one thing that I think will be huge, especially if you think about machine learning moving into healthcare or government or places and areas where litigation is a very real thing, because you can't have a courtroom where you can't explain anything. If all you can do is say this is a black box, then the court session is really short.
Yeah, interesting. So is that the future of law, or is that the future of PR, or is it the future of marketing or sales? How do you?
I think that's the onus is on the technologists to be able to produce technology that you can explain what it's doing.
Yeah.
And then the next thing that I was saying is loosely indirect to machine learning, and I've heard Cuban say some things around this as well, is the notion of ethics and what is right and what we should do. So given the current political climate in the country, I think there's a larger context here with we need a rebirth of values, a rebirth of ethics, a rebirth of what we agree is the way we're going to operate as a community. And I think that's going to play a large part in technology, because the trend I see is everybody thinks just throw more technology at it and that'll fix the problem. And I think we've got a lot of problems where we really need to step back in our humanity and say, you know what, this isn't right. Let's do it this way.
Yeah, it's really funny you mentioned that, because there was a big ruckus around when people ask, I'm going to say her name, but then she'll respond, Alexa. Okay, beautiful. She didn't answer. There she is. Where people were asking these AI tools or these
assistants,
voice recognition tools that are connected to databases, and people are answering these questions, and they're asking them ethical questions, and then these digital assistants offer their answer, and or even religious questions is another one, and then they're offering back some answer that half the world doesn't agree with, right, and have been willing to fight for. And so, okay, that's an interesting little thing we need to be thinking about, because it also, it plays into the idea that you can't put essentially a person, which I'm likening Alexa to, into everyone's house and then say, this person is going to answer all your questions and everyone's going to be happy with all the answers all the time. And so there's other issues with it. So I think it's a very interesting thing, and I think it's a wild thing to wrap your head around. So let me ask you this, and this will be my final question. And if you want to hit any more topics, we're running long here. Is to say, what do you think will be the next big thing in the market that is sellable, or is it that an AI is? Well, let's take AI off the table and say, what else is out there that is going to rock the tech communities and say, this is what the new thing is, the new big data, the new cloud, the new this, the new that, the new IoT?
Good question.
Is it just AI? That's kind of a leading question, because that's all I hear.
I'm thinking. I'm trying to see past AI.
Yeah. This is how you know, for the record, people that watch this podcast, none of this is scripted. While you're thinking of it, yeah, go ahead.
I would like to say the next big technology breakthrough is going to come, or the next thing that's sellable, as you described it, is what I'd like it to be is education. And machine learning probably will be involved with education. There's just a large body of research that kind of shows a better way, a better approach, and I'd like to see it get adopted, because the way, the pace of technology, we've got to educate people in a lot of these things, because we're going to need people that know how to not only develop and design these systems and these AI tools, but we also need people that understand how to work with them, to work in tandem with these tools, with the machine learning.
Right.
And that's going to require education, and education at all levels, not just K through 12, not just figure out a better way to test. I say education in a bigger sense than that, which really is about the curiosity that's required for really learning how to do something. Right.
So to try to make that absolutely practical, like if you're talking to, I promise these will be my last two questions. If you're talking to a college graduate from pick any Big Ten school, and they're trying to think about what the future, what they should go into, where there will be a future for them, what would you say in light of your experience?
Oh, that's a tough one, because I'm still very much of learn something that you're interested in, and you can always figure out how to add value with that.
Right.
And you can always add machine learning on top of art. You can add machine learning on top of music. You can add machine learning on top of sports. The easy answer is to say, oh, go into technology. Everybody needs to be a computer scientist. I disagree with that. No, everybody doesn't.
Well, not everyone can be a computer scientist.
Yeah, that too. So it's still very much learn something that you're interested in and that you have a passion for, but also understand the very real reality that you don't get money just because you have a degree in X. You get money because you can add value as a result of you having a degree in X. So as long as you can keep the proper perspective about adding value, being able to contribute, being able to produce something that's of value to other people, then you should be free to choose whatever major or whatever subject it is that you're passionate about.
Gotcha. And and that ended better than I was hoping it would go, where it's like, I don't know. Because a lot of people watch this podcast and one of our shtick is, I'm trying to convince people that they can do things. And here are some people that have done it, and here are the values that they applied, and here's their responsibility they took, here's how they prepared themselves. Almost every podcast we've done, someone has said, yeah, I didn't know what to do, and I learned how to do it on YouTube, kind of thing. So it's a bootstrap mentality. But then there's this other question I like to ask, and it is this. If I took everything away from you, what would you do? And when I say everything away from you, I mean all your degrees, all of your background, all your money, all of the, even your location. I drop you off in Cleveland, Ohio. It's cold too in Cleveland, but not right now, so you're in luck. And all you have, I'll give you a $100 bill, and I say, Anthony, make your way in the world. What do you do? This is too thoughtful of a response. It's supposed to just be like a gut instinct. Shoot from the head. This is the thing about guys like this, is they're measured. I like that.
I watch individuals for some period of time to really understand who has the access.
Okay.
I tell them my situation. I give them my $100 and let them know I'm willing to do what I need to do.
Okay.
To work.
Interesting. That's an answer we haven't got yet, so I appreciate that. That's good thinking. All right, so that puts us at time here, and we hit on a lot of topics, and we didn't even get through your whole story, which is one of the things we do this in the first place for. So let's plan on doing this again, and next time you're in Austin, we'll sit here and we'll do this live, and we'll tell the rest of the story. Ladies and gentlemen, Dr. Anthony Hylick. Anthony, thanks for your time. We'll do this again real soon.
Lee, thanks for having me. This is an absolute pleasure. Look forward to doing it again.